In May 2024, an active region on the Sun which faced our planet erupted multiple times, sending powerful solar storms directly toward Earth. These solar storms consisted of fast-moving, magnetized plasma that stretched our planet's protective magnetic shield to its limits. As a result, beautiful auroras lighted up skies far from the poles, and significant impacts were shown on our communications and technology. What causes space weather? The solar storms of May 2024 were caused by a peak in the Sun's magnetic activity. As the Sun's magnetic fields became twisted and unstable, they released enormous amounts of energy in the form of solar flares and CMEs. These violent eruptions formed vast clouds of plasma and solar particles through space, creating powerful space weather events that affected Earth and other parts of the solar system. Why was this storm so intense? The Sun does an 11-year cycle of activity, changing between quieter periods and times of intense solar outbursts. As the Sun approaches the solar maximum, the peak of this cycle, its magnetic field becomes more twisted and tangled. During May 2024, these tangled magnetic fields snapped, releasing huge amounts of solar material into space. This release led to one of the most powerful solar storms seen in recent years. Solar flares and coronal mass ejections, CMEs. Solar flares and coronal mass ejections, CMEs, are different but related solar events that happen during solar storms. Solar flares are sudden, very intense bursts of radiation across the electromagnetic spectrum. They are the most powerful explosion not only on the Sun but also in the solar system. On the other hand, CMEs are massive clouds of charged gas, the coronal plasma that are erupted from the Sun over a long period of time and launch into space. In May 2024, multiple solar flares were accompanied by CMEs, resulting in a wave of radiation and particles heading toward Earth. This was the combination that made the storms particularly intense and impactful. The impact on Earth. When the solar storm reached Earth, it pushed the planet's magnetic field, creating a phenomenon called geomagnetic storm. This led to the formation of stunning auroras visible far beyond the polar regions, reaching as far south as the United States and Northern Europe. Alongside these spectacular light displays, the storm disrupted radio communications and satellite systems, demonstrating the powerful effects space weather can have on our planet. Although people on Earth's surface are shielded from space weather by the atmosphere and magnetic field, technology is not as well protected. The May 2024 solar storm disrupted satellite communications and caused problems for radio signals. Power grids faced increased stress as electrical currents surged through the ground. For astronauts and spacecraft beyond Earth's protective shield, the storm posed even greater risks, exposing them to higher levels of radiation. The May 2024 solar storm was a powerful reminder of how strongly connected we are to the Sun's activity. While we can't prevent solar storms, understanding and predicting them helps us to protect our technology and prepare for future space missions. From the beautiful auroras to the challenges faced by our communication systems, space weather, we can understand that despite the fact that we are far from the Sun, we are still deeply affected by its outbursts. As we continue to explore space, studying space weather is very important to ensuring the safety of our planet and future space missions.